Students, in this class we'll see the topic probability 10th standard chapter, the last chapter in the 10th standard. We have been seeing this since class 8th. There is nothing more in 10th standard as well. It's same, but number of questions, different types of questions will be here asked. Otherwise, the whatever we studied in 8th, 9th will is same in 10th as well. Let's recap what we studied. What do you mean by probability? Probability means it is nothing but it's a concept which measures the degree of uncertainty. Probable, yes, I may come probably. Probably it's possible. Probably I can come, right? Means you are sure, not sure, we don't know. There's uncertainty defined there. So this is called probability. What is an experiment? Experiment means, for example, tossing a coin is an experiment. Experiment will always have outcomes. Don't say when we toss a coin in a place where sand is there, it may not give you head or tail. That's why we say experiment should have supported environment. In the supported environment, if you conduct an experiment, it will definitely have outcomes. That's what they do in reality as well. Okay. So experiment. So probability means what? It's the study of chances of events happening. So experiment means it's nothing but operation having some outcomes. We see all for this some examples later. Event is subset of experimental output. Experimental output means tossing a coin is an experiment. It will give head or toss. That is outcomes in the experiment. Getting head is only event. What is the event? It's part of outcomes. Okay, that's event. Having said that, sample space. We'll see sample space widely for different kinds of experiments. It is nothing but total outcomes in an experiment. Total outcomes of experiment. When you toss one coin, what is the sample space? We get head and tail, two. Not in a single experiment. Either head, either tail. So total outcomes is 2. That sample space of an when a coin is tossed, sample space becomes 2. So this like that for 2 coins, 3 coins, how much? When we have a special cards, deck of cards, what is the outcome for that? When you roll a what is the outcome of that? When you roll 2 dice, what is the outcome? Sample space. We'll be studying it in a couple of minutes. So for example, one coin, it is 2. Okay. Then after the sample space, what is sure event? Means event which happens definitely, definite outcome. So it's a sure event. Event which definitely happens is a sure event. So for example, if I say when we roll a die, we definitely get one outcome. That's a sure event. That means the probability of sure event will always be 1. Okay, probability of sure event is always 1. What is this is also called certain event. Certain or sure event, both are same. Impossible event. Impossible event means which doesn't occur, means which will not have outcome at all. For example, probability of impossible event is 0. Example for impossible event, can anyone tell? Yes. When you roll a die, getting 7 when a dice is rolled. Is it not a impossible event? Yes, it is impossible because there is no 7 on the dice itself. So we cannot get that. That's the impossible event. Coming to probability of empirical event. If E is a empirical event, then probability of E is nothing but number of outcomes favorable to E divided by total number of outcomes. It's called sample space. For example, if you want to see if a coin is tossed, what is the probability of getting head? So we'll say let E be the event of getting head. Therefore, N of E is nothing but the outcomes for that event. So what is then N of E value? 1, because one head will be there and one head may come up, we say. It's not that it will come, it's uncertain event, that's why it's said. So what is sample space for this one coin experiment? So one coin will have two outcomes, head and tail. So N of S is nothing but this, we can say formula N of E by N of S. This N here represents numbers of outcomes in favorable to E, number of outcomes in the total experiment. So N of S will have either head or tail. So this is 2. Therefore, we can say N of E equal to N of P of E equal to N of E by N of S, that is 1 by 2. This is the probability of getting head when a coin is tossed. So this is the formula. Probability of event E is equal to number of outcomes favorable to E by total number of outcomes. Okay. There are some rules we need to understand from the probability. These may be asked in exams. Just check out. We are not solving any problems here. We just giving a rule here. What is the first rule? The probability of event is always greater than or equal to 0, less than or equal to 1. Inclusive means probability for any event should not be less than 0, should not be greater than 1. So exam, how they'll ask this case is, for some event E, can this be probability of event? They'll give 4 options. In that they'll say one of the 3 of them are minus, or one is more than 1, one is between 0 and 1. Okay. So you should be able to identify if it is less than 0, it cannot be probability for any event. If it is more than 1, it cannot be probability of any event. Not only that, can this, see, 3 by 2, is this statement true, or can this be probability of any event? It's not only decimal point. If you convert it to decimal point, it will become 1.5, so which is more than 1, so it cannot be probability for any event. Okay, this kind of question will be asked. Next, probability of all events of an experiment, like probability, if one coin is tossed, what is the sum of probability of getting head and probability of getting tail? Means is always 1, no matter how many events we have. For example, if you roll a die, you have probability of getting 6 numbers, right? 1 may come, 2 may come, 3 may come, 4, 5 or 6 may come. What is the probability of sum of probability of all these events getting 1, 2, 3, 4, 5, 6 is always 1. So dash 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 plus P of En is equal to 1. This is very important. Sum of the probability of all the events of an experiment. Then this is one more important, P of E plus P of E bar or dash, anything can be said here, it's 1. Means it is a event. What is E dash? Is a negate of an event. Negate of an event means that event will not happen like that. For example, I'll say the probability of raining today. Okay, raining today is 0.25. What is the probability of not raining today? This is the question they may ask based on this formula. What is the probability of not raining today means if we call raining today as E, obviously not raining today will become E bar. Therefore, P of E bar is 1 minus P of E, that is 1 minus 0.25 becomes 0.75. Understood? Sometimes they'll give directly P of E and they'll ask P of E bar also. This is one of the important formula. All these are important what we are seeing now. There is one more formula which we saw. Probability of sure event is 1. Sure event. Probability of impossible, already we saw this also. Impossible event is 0. Okay. These all 5 are very, very important. Then we will see some sample space outputs here. Sample space. Event and sample space. Very important this is. If one coin is tossed, what is the sample space? It is h comma t, that is 2. H comma t, that is 2. Okay. If 2 coins is tossed, remember we'll learn till 3 coins, that is more than enough. It is 2 coins means for this h and t, don't try to remember what I'm writing now. Just add both h, both t before and after, like this. See, this h is there, so I'll add nh. T is there, I'll add h for that. This becomes one pair. And for this both, you add t once. ht, tt. Okay, this is 4. This is 2 to the power 0, sorry, 2 to the power 1, 2 to the power 2. Because why I'm telling this is, I'll give you question next, you'll understand the application. So you should know how to construct these 4. Don't by heart that. For first one coin output h and t, for the pair you add one time h, for the pair you add one time t at the end. Okay. Similarly, 3 coins are tossed. What is the output? Don't break your head and try to remember, you will forget it. Same 4 set. For these 4, you add h for 4, h at the end one time, t at the end another time. You will get output. See, I'll write hh as is, I'll write one more h, th as is, one more h, ht as is, one more h, tt as is, one more h. So all these I just wrote h at the end to get sample space. Not only this, we have one more t we have to add, right? So comma, same set you take hh t you add, th t you add, ht t you add, tt t you add. So all these underlined things I just added. I did not by heart. Don't by heart as well. Okay. So 3 coins. See this gives coin count. So if I say 5 coins are tossed, what is S? 1 marks question. So it will be 2 to the power 5, that is 32. For that reason only I gave this in exponent form. For 2 coins tossing, the sample space is 2 square, that is 4. For 1 coin tossing, it is 2 to the power 1, that is 2. Like that it will go. So 3 coins is enough. Okay, is it clear? Writing the sample spaces. There may come many questions based on these outcomes. Getting 2 heads, getting all head, getting only 1 head, at most 2 head. So all these we'll see when we see the exercises. Coming to the other experiments, leaving the coins now. Okay, one die is thrown. One dice is thrown. One dice is thrown means dice will have 1 to 6 numbers. So it is 6 to the power 1, 6. 2 dice, when the dice, don't say it's a singular, dice is a singular, die is a plural. So how does this sample space construct? It will be 1 comma 1 means first die you fix 1 and change the second output. like that. 1 comma 4, 1 comma 5, 1 comma 6. Like this is on the one die, one is fixed and second die it can be 1, 2, 3, 4, 5, 6. Like that, next event you fix 2 here in the first die, and again like that it will come 2 comma 6. Like that, how does it go? 6 comma 1 and 6 comma 6. So how many outcomes will be there means 2 dice are thrown here. Just check out the rule. 6 square, obviously 36 sample space. Remember, it's very important topic. Here questions may be coming like, if both dice shows the same number, what is the probability? If 2 dice are thrown, what is the probability so that both the dice have the same numbers? Means you will have 1 1 2 2 3 3 4 4 5 5 6 6. 6 will be event output. 6 by 36 is the probability, like that. So 2 dice. Coming to the cards, we'll see the cards part and we'll wind up the class. How many cards will be there? 52 cards. Out of that, we'll have two sets. If you're not seen, please go and check the cards. There will be black card and red cards. Both will be 26 each. Black will be like this one. This is called spade and this is called what? Clubs. Red cards will be like diamond or heart shape, diamond shape or heart shape. So these 13, this 13, this 13 and this 13. This will be black in color. Diamond and heart will be red in color. Out of these 56 cards, there are some special cards. You know that special cards? Which have not only numbers, the figures will be there. They are called special cards. So coming to that, what are the special cards? They are called face cards. Face cards are called special cards. What are the cards? King, Queen and Jack. Each set will have King. This is 2 sets 13. This is 2 sets, right? So each will have 1 king. So 4 face cards for king. Each will have 1 queen. 4 face cards for queen. Each will have 1 jack, 4 jacks in each groups. So all these things you have to remember, because the question may ask, what is the probability of getting a face card which is a king, and like that they'll say. So king means 4. 4 by 52 is the probability. What is the probability that red king is drawn from a deck of 52 cards? Red king means only 2 cards. So 2 by 52. Like that question will come. When we see the exercise, we will answer. Thank you.